Hello, this is Unit 9, Lesson 4. Learning target, I can solve quadratic equations by completing the square. So the do now says solve by factoring. And we're going to move down, and we are going to solve that by solve all of these by factoring. I'll do the first one with you, and then you can take this second and third to see if you could do it on your own. So you're taking a look at x squared plus 5x plus 6. So we're looking for factors of 6, two numbers that multiply to 6 and that add to 5. And since it's all positive, remember you always start with 1. So 1 times 6 cannot be used. But then you go to 2 times 3, that can be used because 2 plus 3 equals 6. So I'm going to go ahead and put my 2 parentheses down, and just remember it's all equal to 0, and it's x plus 2 and x plus 3. Remember, after that you are splitting it up into 2 separate equations where it's x plus 2 equals 0, and we're going to have x plus 3 equals 0. Just like that. A lot of people do put a line in the middle. You don't have to. It's okay if you don't. You subtract, you solve each equation. This is algebraically, and this is exactly what we want to see as the work. So this cancels, and x equals -2. And x equals -3. You could put an or in the middle of there, and that's completely solving. Go ahead, try to do number 2 the same exact way. You can press pause now. So for number 2, I'm looking at that -20, and I have to have 2 numbers that multiply to 20 and that add to 8. And here they are right here, 2 and 10. So if I do put the, remember it has to be a positive 8. So I'm going to put the plus 10 in as a positive. I'm going to put the 10 in as positive, and the 2 in as that negative. And remember, 10, you could check it out. 10 times -2 is -20. 10 minus 2 is positive 8. Remember that all equals to 0. So we're going to split that up. X plus 10 equals 0. And we're going to split that up into x minus 2 equals 0. All right, and then we solve each side. So you're subtracting 10 on this side, adding 2 on this for this equation, plus 2 on either side right there, and a minus 10. So we have, canceling out here, x equals -10, and or x equals 2. Those are the roots of that quadratic. Go ahead, try number 3. Just remember, see this 15 right here? Has to be brought over before you do anything. And this is going to be factoring using grouping. All right, so go ahead, see if you can solve that algebraically using grouping after you bring that 15 over to the left-hand side. Press pause now. So, okay, we have 4a squared minus 4a equals 15. You subtract 15 on both sides to get this like this, 4a squared minus 4a minus 15 equals 0. You do 4a times c, 4 times 15 is 60. So you're looking for multiples that you can multiply to 60 and you can add to negative 4. All right, so that's going to be a little bit difficult, right? 1, I start with 1 times 60. Can't make 4 out of it. 2 times 30, multiply to 60, but no, can't make 4. 3 times 20, 4 times 15, still can't. 5 times 12, still can't. 6 and 10. All right, so 6 and 10 multiply to 60. And also, if you take positive 6 minus 10, you can get to a negative 4. So that's what we have here. I have 4a squared. Instead of this negative 4a, I am going to put positive 6a minus 10a. Remember, that will equal that negative 4a. All right, so now we go ahead and take out the greatest common factor of the first two factors right there. 2a is the greatest common factor times what equals 4a squared. 2a times 2a equals 4a squared, and 2a times 3 equals 6a. And that 2a plus 3 should be on the other side too. But the greatest common factor of 10a and 15 is 5. So 5 times what equals 10a? There it is. There's the 2a. And negative 5 times what equals negative 15? That is positive 3. So you take a little look at it, inside the parentheses, remember, is the same. So now you're making your binomials, and you are going to put 2a minus 5 in one parenthesis, and then inside the other parenthesis, you're going to have 2a plus 3. And all of that equals 0. Remember, you didn't solve it yet. You just factored it. It says solve by factoring, right? So we're going to split this up. So I split them up like this. 2a minus 5 equals 0, and 2a plus 3 equals 0. And now I am going to solve. Just like this, and you add 5 on both sides. Add 5 on both sides, minus 3 on both sides, divide by 2. 5 divided by 2 is 2.5, and a equals negative 1.5. And those are the roots, and that finishes that that question, that third question on that do now. Okay, so solving quadratic equations by completing the square, I think it's very annoying, but they sometimes ask, especially on the Regents, for the second or third step. So it's very important to know at least the steps on how to do it and to answer some of these questions. You'll see some of the questions later on. So to complete the square for an expression in the form x squared plus bx, you follow these steps. And these steps will make a little bit more sense. And these steps will make sense later on. So step 1, find 1/2 of b, which is the coefficient right in front of that x. Then square the result. Then add the result from step 2 to both sides of the equation, factoring the equation, the resulting expression, as the square of the binomial. So we'll get into this, and we'll actually do one right here. Okay, so it says solve by completing the square. In your lesson, you have all the steps here, but we're going to go through them step by step because I think that it's important to actually watch how it's done, and then you know, kind of like put it into practice with different practice problems. So the first step that we said that we were going to do. It says find 1/2 of b, right? So I'm going to go back to this, and b is -12. All right. So find 1/2 of b. Sorry, that's the wrong. Find 1/2 of b, and then square it. You take a look at what I did. I put b down right here as -12. -12, find 1/2 of b, which is -12 divided by 2. And you get -6. Put that, remember, you have to have parentheses if you're going to use your calculator here. -6 squared. All right? Then you square it. So it's basically like doing 12 divided by 2. -12 divided by 2 is -6. -6 squared is 36. So this is basically what you write down. You have the x squared here. You're going to have everything down as far as... So take a look at what the third step says. Add the result. After you square it, add the result from step 2, which is 36, to both sides of the equation. So that's what we're going to do. We have -6 squared, which is 36. We took the -12, we divided it by 2, then we squared it, and then it's 36. We add that to both sides. So the result is something like this. It's x squared plus minus 12x plus 36 equals 40. Just like that. So now you have to factor this quadratic, right? So we added the 36 on both sides. We have x squared minus 12x plus 36 equals 40. And now we're going to have to factor the quadratic into two binomials, just like we normally are used to doing. So we're going to leave that 40 there, though. So we're looking for factors that multiply to 36 and that add to 12. Well, I could think of 6 times 6. So, but it has to multiply to a positive and it has to add to a -12. So we're talking about positive times positive or negative times negative. It cannot be positive times positive because this is not positive 12. So it has to be negative times negative. So we're going to put a -6 there, and we're also going to put another -6. And just like that. So once you have them like that, you could just go ahead and split them up. Split and solve. Just like this says right here, split and solve. So just take a look at this. X minus 6 times x minus 6 is this. X minus 6 squared equals 40. So how do we solve a square root? How do we solve for that square root? We go ahead and square root both sides. We're going to square root both sides because we need to get that squared out of there. And we square out that 40. So the square root here cancels with this square, and you have x minus 6. X minus 6 equals the square root of 40, which is the positive side. And you can actually put it like this, positive and negative. Remember, there's two different answers. There's a positive, and then there's a negative as far as this square root goes. So look what I did. I put x minus 6 equals a positive square root of 40, and then x minus 6 equals the negative square root of 40. So now when you add 6, you solve on both sides. This cancels. X equals 6 plus the square root of 40 and this you add 6 on both sides here again, and you have x equals 6 minus square root of 40. Okay, so you have to simplify the radicals, right? And if you watch the video that I did on simplifying square roots that are not perfect squares, you'll know how to do this. If you don't, then I will just go through a really quick simplification problem here. All right, so if you have the square root of 40, let's just say you have the square root of 40, and you do right here, you have to simplify that into a perfect square times a non-perfect square. And the perfect square, the two numbers that I'm thinking of is 4 times 10. And we're always looking for a perfect square and another perfect square. So I would start off with 1 times 40, right? And then I would say, all right, none of those numbers are perfect squares. And now I have 2 times 20. Those are not perfect squares. And then I get down to 4, and it's 4 times 10. So 4 times 10, 4 is the perfect square. So I'm going to put that in the first square root radical house there. And I'm going to put, so it is 6 plus, I have here 6 plus square root of 4 times the square root of 10 equals square root of 40. Square root of 4 is 2. So the way you write that is 6, I'm having trouble writing here, plus 2, because the square root of 4 is 2, square root of 10. You cannot add that 2 and 6 together, because this 2 is being multiplied. This is 2 times square root of 10. So you can't just put 6 plus 2 together. All right, it's like order of operations. So we have x equals, and we're going to put that into the calculator, 6 plus 2 radical 10. And the way you put that in, just like this, 6 plus 2 square root 10. Just like that. And you press enter. And it is approximately, and we're going to round it off, 12.32. I'm having a lot of trouble with the keyboard here. All right, so 12.32 approximately, and sometimes you write those wavy equal signs. They're kind of like a wave there. That's just for approximation. All right, it's around that. So taking a look at this side, we have x equals 6 minus, and we have the square root of 40, right? So we have that square root of 40. I'm going to change that. I'm going to simplify square root of 40 into square root of 4 times the square root of 10. And the reason why I'm doing that is because 4 times 10, 4 is the perfect square. You need one perfect square to simplify, right? So square root of 4 is 2, and that's where this comes from right here, and it has 2 square root of 10. The square root of 10 stays inside that radical. So we have x equals 6 minus 2 square root of 10, and we have x is approximately equal to negative 0.325, and these are the roots. All right, that's how you solve by completing in a square. All right, and we'll go over another one with you definitely. Let's try another example right here. All right, so we have steps on that first page. Right? So the first thing that we are going to do is to identify b. And that's what I do all the time. B equals negative 20. The second thing I have to do is to divide the negative 20 divide that negative 20 by 2. These are the steps all of the time when you're using completing the square to solve. So we have negative 10. And then the last thing that we have to do is square it. So it'll always, even if it's negative, it'll always turn positive, right? It'll always be that positive answer, so it's 100. Just like that. So that's what I do first, but I'm looking at this right here, this plus 32. I don't want it on my left side, all right? So I want it on that right side. So I'm going to just go ahead and subtract that 32 from each side. Just remember, whenever you have that C on the left side when you're completing the square, go ahead and put it onto the right-hand side. So you have x squared minus 20x. And now that we have 100 here, I'm going to add, my third step would be to add 100 on this side, on the left side, and then equals negative 32 I have, right, plus 100. Remember, whatever the square is, whenever you get through this, all right, you're dividing by 2, you get negative 10, you square it, you get 100. You add that 100 onto both sides. So what it comes out to be is this. You have x squared minus 20x plus 100 right there equals, and then negative 32 plus 100 is 68. So what this does is that it creates a situation where you're going to square both sides, and you're going to have two binomials that will be equal to each other, right? It's going to be the same binomial. So what times what equals 100 and adds to a negative 20? Well, that's minus 10. X minus 10 times x minus 10. And you see how it's the same. So what it comes down to is x minus 10 squared equals 68. And this is the completing the square part. So it's just like that. X minus 10 squared equals 68. And what do you do to undo a square? What's the inverse operation of squared? Square root both sides. In my atrocious handwriting, we have x minus 10 squared equals 68, and you square root both sides to get rid of the square and the square root. So what you do have is x minus 10 now outside the radical. There is no more. It's not underneath the square root, and it's not squared. And then it's plus minus, because remember there's two answers. There's always a positive and a negative for an answer to a square root. So we have something like that. When we split it up, it's x minus 10 equals square root of 68, and x minus 10 equals the negative square root of 68. Okay, so I split it up right here. And I'm going to take the calculator, and 68 is something that I cannot even simplify. There is no number that goes into 68 that is a perfect square. So we are just taking the square root of 68, and we are going to round it to 8.25 as it is on the calculator. So we have x minus 10 equals 8 and it's approximately 8.25. We're rounding it. And x minus 10 equals negative 8.25. And like I said before, you could use those squiggly equal signs on these because it's approximate right now. So we add 10 on both sides. We're adding 10 on both sides. Here, the 10s cancel. You have x equals and I'm going to do the squiggly equal sign, 18.25. That is one root. That is going to be off your screen if you have it on the calculator, because the calculator is 10 by 10. Usually you're going to have to extend that screen, and this cancels. You have x equals a positive 1.75. And that 1 does not look good. And that is completing the square. Remember, I always go for b first. We have that b is negative 20, the coefficient. You divide it by 2, you square it, you get 100. You always take that c and move it over to the other side. Because what you're going to do is you're creating a situation where you can, you're going to have binomials that are the same. All right, so you add that 100 on both sides, and you get x squared minus 20x plus 100 equals 68. And what this does is that it creates the same binomial for each. So when you do have x minus 10 times x minus 10 equals 68, you're squaring, you have it squared. Whatever that binomial is going to be squared. And then you square root both sides to undo the square. Once you square root both sides, this is the situation that you have. All right, it's complicated, but you definitely will get used to it. We'll do number 1 together, and then you could start to take number 2. Remember, I mean, if you want to start off with this, you don't have to start off with the b, divided by 2 and squaring it. You could just add that 5, and you will get that w squared plus 6w equals 5. All right, might be a little bit easier for you to see. All right, so we're going to just take b. I'm going to take b. We're not going to take b, or we could take b, or I could take b, and b is 6. I don't know. And I am going to divide it by 2. So now it's going to be 3. And I'm going to square it. And 3 squared is 9. Like, not bad, right? So what you have here now is w squared plus 6w, and that equals, plus 9 equals, because you add the 9 to the left side, but you do have to add the 9 to the right side. 5 plus 9. All right, so this is what you have. You have w squared plus 6w plus 9 equals 14, because you have to add that 9 on both sides once you square it, right? So now you're going to look for factors that multiply to 9 and that add to 6. Since this is all positive, guess what? 3 and 3. That works just fine. Just like that. Still equal to 14. So we have w plus 3 squared and that is equal to 14. Again, the way you undo the square is to square root. So you're going to square root this whole side, and you're going to square root the whole right side. So the square and the square root are opposites, so just the w plus 3 will come down, and you have plus or minus the square root of 14 because you square root, and every square root has a positive answer, and it also has that negative answer. So we have w plus 3 equals plus minus square root of 14. We split it up to I split it up to w plus 3 equals 3.74 because square root of 14, as you can tell right in my calculator, is 3.74. And then w plus 3 equals negative 3.74. Now you solve both sides like you normally would. Okay, and we subtract 3 on both sides. For the left equation, you have w equals 0.74, and you subtract 3 on both sides of the right side, and you have negative 6.74. That's it. Go ahead, see if you can do number 2. Hopefully you can. The 11 is over on this side already, so go ahead, go through the steps, and see if you can work it out. You can press pause now. So hopefully you did do some of this right here. You have x squared minus 10x equals 11. You have x squared. You take in b, which is negative 10, and I just put 10 down because it's going to turn positive anyway. It is negative 10. No, negative 10 divided by 2 would be a negative 5. Negative 5 squared would be 25. It's the same thing. So we have 25 added to both sides. We have this plus 25, and we have 25 plus 11 on this right side. So we have x squared minus 10x plus 25 equals 36. Again, I told you that the binomials, this creates binomials that are exactly the same. X minus 5 times x minus 5, negative 5 times negative 5 equals positive 25. Negative 5 plus negative 5 equals negative 10. So that's when you have x minus 5 squared equals 36. You are going to square root both sides. And we have x minus 5 equals 6 because this square root on the right hand side did turn out to be a perfect square of 36. So square root of 36 is 6 and negative 6. Remember, you have to have that positive and negative. So what happens on this side is that you add 5, you have x equals 11, and then you add 5 on this side also, but it's negative 6 plus 5, and that's negative 1. So those are your roots. That's how you do it. Number 2. Go ahead, see if you could do number 3 on your own, and we'll come back with the answer. Remember, this 11 has to be moved over to that right-hand side, so probably the first thing that you should possibly do is subtract 11 on both sides. Go ahead, you could press pause and do this problem now. So take a look. I took b, I subtracted 11 on both sides. P squared minus 12p equals negative 11. Then I took b, which is negative 12, divided it by 2, which is negative 6. Negative 6 squared, I forgot to put that squared down, is positive 36. Once I had positive 36, I added that to the left side, and I also added that to the right side. And I came out with p squared minus 12p plus 36 equals 25. Negative 11 plus 36 is 25. Again, that's a perfect square. So now I would just do p minus 6 squared, because that's what that is, equals 25. And you have to solve, so you square rooting both sides just like that, and you square root that right side. So you have p minus 6 equals plus minus square root of plus minus 5, because the square root of 25 is 5, so we can just put it like that. And we have p minus 6 equals plus minus 5, plus 5 on both sides, plus 6 on both sides, and you get p equals 11. And then on this side, you add 6 on both sides, you get p equals 1. These are the roots. Go ahead and see if you could move over to number 4 and try that out. Remember, this negative 71 is in the right spot already. You don't have to do that minus 11 thing that I did here for number 3. Go ahead, try that problem. Now you can press answers. Okay, so we have q minus 22q equals negative 71. I divided the negative 22 because it's the b, it's the coefficient. You divide it by 2, you get negative 11, and you do negative 11 squared is 121. 121 gets added to the left side and also gets added to the right side. When you add 121 to the left side, this is what you get, and then you get 50 on the right side because negative 71 plus 121 is 50. Q minus 11 times q minus 11, again you created that perfect square of 121. Negative 11 times negative 11 equals 121, and negative 11 plus negative 11 equals negative 22, all equal to 50. You have that q minus 11 squared, you square root both sides, you have q minus 11 equals plus or minus the square root of 50, you figure that out, you solve both sides, you get q equals 18.07 or q equals 3.93, and that is the answer to number 4. Alright, hopefully you were able to follow along. If not, you could always rewind and play the video again if you would like. So to complete, we're going to write a rule to complete this square. To complete the square, take half of the coefficient. So this is half. So we're taking half of the coefficient of the x term. That's the b, right? And square it. Square it. Then you are adding this number, whatever that is, squared, to each side of the equation. So go ahead, see if you can do 1 and 2. We'll come back with the answers after you press pause and try them. Go ahead. Press pause and try these 2 questions now. Okay, so number 1, you have, I took 2 divided by 2, you get 1. 1 squared is 1. That's why I added 1 on both sides. You have x squared plus 2x plus 1 equals 4. You square root both sides. Because you have square, you want to do the square. You have x plus 2 equals plus or minus 2 because the square root of 4 is a perfect square, and you get 2. You solve both sides, you get x equals negative 4 or x equals 0. On the other side, I took negative 6 divided by 2, you have negative 3. Negative 3 squared is 9, so I added 9 on both sides. X squared minus 6x plus 9 equals 25, another perfect square, which is really good. You have x minus 3 squared because x minus 3 times x minus 3 equals the factored form of x squared minus 6x plus 9. So you square root both sides and you get x minus 3 equals plus or minus 5. You solve both equations and you get x equals negative 2 or x equals 8. Hopefully you got those, and we could do number 3 and 4. Go ahead, try them now, and we'll come back with the answers. You could press pause now. Okay, so number 3, I took 4 divided by 2, and it's 2. 2 squared is 4. Remember, always subtract the 7 on both sides because you need that c over to the right hand side. Then I added the 4 on both sides because that's what I got when I squared that 2. And I came out with x squared plus 4x plus 4 equals negative 9 because negative 6 minus 7 is negative 9. When I factored x plus 2 times x plus 2 equals the x squared plus 4x plus 4, very easy because it's all positive, equals negative 9. Then you go to square root both sides and you realize you cannot take the square root of a negative number. So that's it. There is no solution right there. So on number 4, same thing. So we have plus 7 on each side. You have x squared plus 5x equals negative 7. I took the 5 right here, which is the b, divided by 2. It's 2.5. 2.5 squared is 6.25, so I added that on both sides. I have x squared plus 5x plus 6.25, which is a perfect square. So we have x plus 2.5 times x plus 2.5 equals, and this it comes out to be a negative. There it is again. If we square root both sides, it is taking the square root of a negative. We cannot take the square root of a negative, so there is no solution for number 4 as well. So on to the next two, the last two of the challenge questions, solved by completing the square. You can press pause and we'll come back with the answers. Press pause now. Okay, so number 5, we have x squared plus 12x plus 3 equals 1. You subtract 3 on both sides first off, and then you have x squared plus 12x equals negative 2. 12 divided by 2 is 6. 6 squared is 36. You add 36 to both sides, and you get x squared plus 12x plus 36 equals 34, because 36 minus 2 is 34. You have x plus, when you factor x squared plus 12x plus 36, you get x plus 6 times x plus 6 equals 34. That is squared. You square root both sides and you get x plus 6 equals, you take the square root of 34 in your calculator, you get negative 5.83 and positive 5.83. You solve both sides and you have one root as negative 11.83 and one root as negative 0.17. For number 6, this is a coefficient that needs to or should be reduced. So what I'm going to do is I'm first going to just go ahead and divide by 2 here on each of these numbers, because they're all multiples of 2. So once I get finished with that, the 2's here cancel and we have x squared, which is nicer. And then we have 4x, because 8 divided by 2 is 4. And then we have 5. And you see how nice it actually comes out to be. Okay, so we have the, when I divided by 2, I made it much easier. I took the negative 4 divided by 2. It's negative 2. Negative 2 squared is 4. So then I added 4 to both sides, and I got x squared minus 4x plus 4 equals 9. 5 plus 4 is 9. When I factored this trinomial here, I had x minus 2 times x minus 2 equals 9, and I square rooted both sides because I need to get rid of that square, and I have x minus 2 equals plus or minus 3. I split up the equations and I solved. I had x equals 5 or x equals negative 1. Just as you see right here, that's basically it. Alright, so here are some Regents questions, and the Regents questions are sometimes easier because it doesn't ask you to go through the whole process, but these are what Regents questions, past Regents questions look like. Try to do numbers 1 and 2. I'm talking about this one, and then we'll come back with the answers to explain them. Press pause now. So take a look at number 1. I added 7 on both sides. This is what I'm saying about not going through the whole process. By completing the square, it says by completing a square, which is a step in that process. So you add 7 on both sides, you get x squared minus 8x equals 7. And then you take that negative 8 and divide it by 2, which is the b, and then you square it and you get 16. So I added 16 to both sides, and it became x squared minus 8x plus 16 equals 23. When you add 16 to 7, you get 23. And I factored and I came out with x minus 4 times x minus 4 equals 23. That is number 2, and that's why I got that answer. Okay. Try this one right here. The quadratic equation x squared minus 6x equals 12 is rewritten into the form of x plus p squared equals q, where q, we're talking about this one, is a constant. What is the value of p, which is right here, is what they want. All right, so go ahead, just go through the steps. You'll get it. Press pause now. Okay, so I took -6 divided by 2, which is b, which is -3, and that's what this is right here. I just went through. -3 squared is 9. I added 9 on both sides, just made sure that this was what I had here. If they asked you q, it would be 21. That's basically it. So you could stop right there, and number 3 is your answer. 3 is your answer. All right, so which equation has the same solution as x squared plus 8x minus 33 equals 0? Try it again. You see where they're leading you here, so you just go ahead and use completing the square to determine which one has the exact value of x. Press pause now. Okay, we add 33 on both sides. We have x squared plus 8x equals 33. I took 8 divided by 2, and that's 4. 4 squared equals 16, and I added 16 to both sides, just like you see here. X squared plus 8x plus 16 is x minus 4 times x minus 4. But the thing is here, 37 plus 16 is 49. That's why 1 is your answer. It's x plus 4 times x plus 4. All right, all positives, and then it equals 49. So that is your answer. Go ahead, do the same thing for this one. Press pause now. Okay, so we added 12 on both sides, just like we did on the other one right here. So we had x squared minus 6x equals 12. I took the -6 divided by 2 and then squared that. Answer is -3 squared is 9. Then I added 9 on both sides. I had x squared minus 6x plus 9 equals 21. I knew it wasn't 3 or 4. And then when you factor x squared minus 6x plus 9, it comes out to be x minus 3 times x minus 3, because -3 times -3 equals 9. -3 plus -3 equals -6, and 2 is your answer. Go ahead and do this last question. Press pause now. Okay, so I subtracted 6 on both sides, and I got x squared minus 8x equals -6, like you see right here. And you have x squared minus, and then I took -8, which is your b, and the coefficient of that in front of that x, divided by 2. You get -4. Then I squared that answer. -4 squared equals 16. Then I added 16 to both sides. And when I add 16 to this side, it looks like x squared minus 8x plus 16. And 16 minus 6 is 10. So then I factored x squared minus 8x plus 16 into x minus 4 times x minus 4. And that still equals to 10, and I put it squared because it's the same thing. You square root both sides and you solve, and you have x equals 7.16, and x equals 0.84. All right, and that is an open-ended regions problem. Okay, very quickly, vertex form of a quadratic y equals q minus h squared plus c. And this is what we've been dealing with right here. It's called vertex form, where h, this part right here, is the x-coordinate of the vertex, and c, this part right here, is the y-coordinate of that vertex. The amount you translate up and down as far as that y goes. So if you have something like this right here, you have y equals x plus 3, which means remember, left 3 and down 2. Right? So that's what that means right there. And I just had to make some room here because they want the standard form of this vertex form. So what you would do is that you would just go ahead and expand So x plus 3 times x plus 3 minus 2. That's all y equals, right? So then you would do distributive property, and you would get, and just quickly, x squared, x times x, plus 3x plus 3x, x times 3 is 3x, and then this is 3x also. 3x plus 3x, another 3x, and then 3 times 3, which are the last 3 times 3, which is 9. And all of that is, and then also minus 2. Don't forget about the minus 2. That's y equals. So standard form is just combining like terms here. So we have y equals, let me just put it over here, y equals x squared uh, 3x plus 3x is 6x, and then 9 minus 2 is positive 7. And that is the standard form of this right here. So all you would have to do is actually just expand it, do distributive property, and then combine like terms, and you get your y equals x squared plus 6x plus 7. All right, so for trying these, this is where the vertex is. So it says write the function for each of the following listed vertex points and describe the translation of each. Let me just get this over here. Before we go on further, I just wanted to make sure you understand h, whatever is in the h, whatever is h is either going left or right, right? If it's a minus, it goes to the right. If it's plus, it goes to the left, right? This right here, plus c is the x coordinate, the amount you translate either up or down. So plus would be up, minus would be down. All right, so just wanted to go through that. So if you have a vertex that is 4, 2, from the 0, 0, from 0, 0, from the origin, how many spaces, like where is that vertex? That would be very helpful, right? So it's actually 4 to the right. Right? Think about where 4, 2 is. 4 to the right and 2 up. Right? So if it's 4 to the right and 2 up, you're going to put y equals x, 4 to the right minus 4, squared, and then up 2 plus 2. That's all they want you to do. Right? Think about it. Just take where that vertex is. That's at 4, 2. So that means it's 4 to the right and 2 up. So vertex number 2. Let's see if you could do this one. Negative 3 is 3 to the left and 1 down. So what does that function look like? Y equals 3 to the left. So x minus a negative 3. Make sure you put that double negative down, so that's going to be plus. Squared down minus 1. And that's it. Go ahead, try number 3 and 4 on your own. You can press pause now. And there's number 3 with 5 right and 2 down. We have y equals x minus 5 because it's going to the right, 5, squared minus 2 because it is going down. All right. Minus a negative 2, actually. All right, so, sorry, plus negative 2. And that's down 2. The vertex, negative 6, comma 3, is right here. 6 left, 3 up, and I converted it right here. And those are your answers. Okay, so the vertex, and this is basically use the vertex, the standard form, and of this quadratic function. See if you could do it. You could press pause now. All right, so here we go. The vertex is 1, negative 3. Hopefully you got that. It's right there. And it is 1 to the right and 3 down. So it is y equals x minus 1 squared in parentheses minus 3. This is the vertex form. Standard form of this is just expanding the x minus 1 times the x minus 1. And don't forget, you still have this minus 3. When I did distributive product, I got x squared minus 1x minus 1x. And then plus 1, because negative 1 times negative 1 is a plus 1. That 1 minus 3 is that. That's why you have that negative 2, and that negative 1x and negative 1x is negative 2x. This is standard form. If you graph this in your calculator, you will see this, or you should see this, and that means you're correct. So this is asking you to go in reverse. And you could do it a couple of ways. You could either use your calculator. Is definitely the best way to go about this. So I'm going to move this over here, and I'm going to make it smaller. I'm going to bring up that calculator. When in doubt, use the calculator. So I brought up my calculator. I'm going to put x squared plus 10x plus 19, because we want the vertex form. So if you get the vertex, guess what? That means you'll have vertex form. So we have right here the vertex, which is right here. So what we're going to do is we're going to press second function, and we're going to look for that minimum. The reason why we know it's a minimum is because it's a parabola that is facing up, and that vertex is at the lowest point. So I'm going to go left bound, and then I'll go right bound, and then I'm going to guess, and I'll move it right there, and the minimum is -5, -6. So the vertex is -5, -6. So always use that calculator. Now that you have the vertex, now you could just say, all right, the vertex is 5 to the left and 6 down. And you could see that right on the calculator. But the reason why that's really important is because now you could actually pick out what the vertex form is. So we have 5 to the left, so it's y equals x minus, because x plus, so basically right here is, so we have x minus -5, which is what that vertex is, and then -6, and C is your answer. Go ahead, solve this equation by completing the square. You have x squared plus 4x minus 12. Remember, you always start with this, but I want you to go ahead and try this on your own. See if you could do it. Remember, you have x squared plus 4x equals 12, and go ahead, see if you could work it through. Press pause now. Okay, you can see what I did right here. I took 4 divided by 2, and I got 2. The 4 comes from this right here. 2 squared equals 4. Then I added that to both sides here. You have x squared plus 4x plus 4 equals 16, because 12 plus 4 equals 16. Square root both sides. When you factor x squared plus 4x plus 4, you get x plus 2 squared. X plus 2 times x plus 2. Square root both sides, and 16 happens to be a perfect square. You have x plus 2 equals 4, and x plus 2 equals negative 4. You subtract 2 on both sides, you have x equals 2, or x equals negative 6. What we're going to do right now is just to make sure that that is correct. Like those two roots are correct. So I'm going to put that, I'm going to check it in the calculator. And this is what you should do pretty much all the time, especially on a big test. As I don't know what I'm doing here. Okay, minus 12. I'm putting the original quadratic in. It's x squared plus 4x minus 12, and we're going to press graph. So see this right here? That's one root. That is 2, and I have a negative 6. X equals 2. Or x equals negative 6. Negative 6 is right here. 1, 2, 3, 4, 5, negative 6. All right, so I got that right, and it is correct. Checking your work from the calculator. Use it. Graphing calculator all the time. Go ahead, see if you could see what Jamie did. She might have made an error. So go ahead. This is the exit slip. Press pause now. Okay, so the first thing that I do when they say there's an error, obviously there is an error. So you subtract 7 on both sides. We're going to complete the square here. So 7 cancels, and we get x squared minus 14x equals 11. So then I just took 14, negative 14, divided by 2, and that became negative 7. That answer is negative 7. Negative 7 squared, negative 7 times negative 7 is 49. So I would add 49 to the left side and add 49 to the right side. This is what it's supposed to be. This is what she has. So what can she do to correct this error? She could add 49 to both sides. She forgot to add 49 to that right side, and that was her error. That's it. Unit 9, Lesson 4 is done. Hope you found it helpful. See you guys later.